So let's consider the derivative of an inverse function. So if we let f be a function that is differentiable on an interval I. If f has an inverse function g, then g is differentiable at any value of x for which f prime of g of x is not equal to 0. And they go on to tell us that g prime of x is equal to 1 over f prime of g of x, which we just showed on the last slide, that f prime of g of x is not equal to 0. Another way of writing this is that dy dx is equal to 1 over dx dy. In other words, 1 over the reciprocal. So steps for finding the derivative of an inverse function. If we are to find f prime of f inverse of b, and so they tell us that f prime of f inverse of b, that's the same as f inverse of b prime. In other words, that's the derivative of the inverse. So for a point AB on the function f of x, notice that A is an x value, B is a y value. So the first thing that we need to do is to find what the derivative of f of x is, so f prime of x. And if they have only given us b, which is a y value, remember y is equal to f of x. And so what we can do is take b and set it equal to f of x, and then solve for a, which is the x value that we need. Next, we will substitute a into our derivative that we found in part 1. So we find f prime of a. And then the last thing we can do, since we now know f prime of a, is that we can take the reciprocal of this. So f prime of f inverse of b, or f inverse of b primed, is going to be equal to 1 over f prime of a.